Hi and welcome to today's video. We are looking at a brand new math concept. We are looking specifically at patterning and algebra, and we're going to get started with a couple of different concepts here. So the first thing that we are going to be looking at is this pattern over here, where we see that the pattern is growing each time. So in my first number has a value of 3, second is 5, 7, and 9. Now it doesn't take a genius to figure out that we are going up by 2 every single time, but we've got to figure out what the pattern rule might be, or if we needed to figure out what maybe the 10th or the 100th or the 30th number or the negative 50th number would be if we were to continue growing in this pattern. So let's see how this is done. The first thing that we should probably consider doing is reorganizing this a little bit so that way we can look and use some different numbers. So first things first, what I'm going to do is I'm going to label these numbers. This is my first number, that's my second number, my third, and my fourth. And you might be thinking, well, why is he doing that? I'm going to create something called a table of values. And a table of values is going to help me visually when I am actually working through this algebraic expression. So I'm going to put the term over on this side, and I'm going to put the value on this side. And I used two different colors to show this. The term numbers are always going to be in the order that the numbers appear. So my first number had a value of 3. So I'm going to switch the value over here to 3. My second number, so the second number in the sequence, had a value of 5. My third number had a value of 7, and my last number had a value of 9. Now, if you look at this, you can see that every time the term changes, we are adding 2. 3 plus 2 is 5. 5 plus 2 gives me 7. And then 7 plus 2 is 9. And that's going to continue on, we're going to assume, because it seems to be pretty common right here. So this plus 2 is really important when we're trying to solve an algebraic expression. It is going up by 2 each time, or each term. In this case, I'm going to just label that n. So what this means is that as the term number increases, it's going to add 2 based on what term number we're at. So if I'm at term 1, it would be 2 once. If I'm looking at term 2, it would be 2 groups of 2. There's the 2, it would fit into here. Same thing if we went to the 3, to the 4, to the 5, to the 10, to the 100th, or whatever. Now let's see if this pattern rule actually works. So if I was to take 2n, so if I took 2 and multiplied it by 1, my first term, I get a value of 2. But that's not a 2. That's a 3. Well, let's think about this. How can I get a 2 to 3? Well, I can simply add 1. And if I add 1, potentially that's going to allow it to work. So we're going to double check this math and make sure that it actually works out. So what I have here is if I was to actually solve the math, if I had 2n plus 1 is my pattern rule, and I went 2 times 1 plus 1. 2 times 1 is 2 plus 1 gives me 3. My first term should have a value of 3, and it does. So I know that that works. Let's do it over here with 2, let's pick this one. So let's go 2 times 3 plus 1. 2 times 3 is 6, plus 1 gives me a value of 7. So my third term should have a value of 7, and it does, so I know that it works. So this pattern rule right here is going to fit for this pattern. Now, this n is a variable. And in algebra, a variable means that it can change. It can vary. So if we needed to find the 100th term, we can simply plug 100 into this term, and that will give us the number that we're looking for. Or if we needed to do the negative 100th term, we can plug in a negative 100 there. So this algebraic expression right here will work for us to solve any value that we needed in terms of the term number that we need. Let's take a look at this one. This one's a little bit different because what we're seeing here is that we are now seeing, whereas this one was growing by 2, this one is decreasing by 2. And there's a little bit of an issue when they're decreasing, and I want to talk to you about it real quick. So immediately what I'm going to do is I'm going to do my table of values again. I'm going to put my first number, okay, my first number was 3. My second number is 0. My third number is negative 3. And my fourth number is negative 6. Now what is happening in here? We can see that there is a pattern happening that it is subtracting 3 every single time. So as the term changes, we are subtracting 3. So we're actually getting smaller as the term grows. Now that's kind of important. Over here, what we did was we took the pattern, the +2, and we threw it to the front of our expression. And then we placed a variable behind it. What I don't want you to do, which is fairly common, is that kids will often say n, or whatever the term number is, -3. Now look at that for 1 second and compare it to that. How would we know if we were going to multiply this or if we were going to subtract it? The answer is that we don't. So we're not going to put our letter first. We always want to start with our constant first. And the constant in this case, which is never changing, is that in this case, the -3 is going to come first. And then we are going to multiply it by the term number to get an answer. So let's see if the math works. I got a 3 here and an n, or -3 and an n. And if I take a look, -3 times 1, so let me plug that in, -3 n. -3 times 1 gives me -3. But I don't need -3. I need +3. So I need to think to myself, if I'm at -3, how do I get from -3 all the way to +3? Well, if I'm at -3 to get to 0, I have to add 3. And then if I'm at 0 to get to 3, I have to add another 3. So I've got 2 groups of add 3, which means I'm adding 6. So I'm at -3 plus 6. And now that I have this, I can double check and make sure that it works. So if I was to take this and I was going to plug in, let's say, the first term, times the 1, because 1 from here gets plugged into n, plus 6. -3 times 1 is -3, and I'm going to add 6 to it. If I add 6 to it, I end up with +3. +3 is what I needed. Let's try one more. If I have the same thing, I'll do it over here. If I have -3n plus 6, and I plug in the second term, -3 times 2 plus 6, so second term, which is what goes there, I have -3 times 2. Well, negative times a positive is a negative, so that's -6 plus 6. My answer should be 0. And it just so happens it is 0, so I know that -3 plus 6 is going to be my pattern rule for this. So let's recap, because I got a lot of stuff on this board. What you want to do is you want to try to determine what the pattern is. So add 2, add 2, add 2, or subtract, 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 and that is going to become the front of your pattern rule. When you've got that pattern, immediately put a variable behind it, because you are going to be multiplying that pattern by the term number. Then check and make sure that you actually get the value that you need. If you don't, you have to then add or subtract to get to where you have to go. One last thing, don't forget that you always want to put the number in front of the variable so you can show the multiplication. Otherwise, it gets a little more confusing. And that's how you'd solve for a pattern rule. If you have any questions, by all means, please drop a line. And if you need to rewatch the video, it is here for you to rewatch. Thanks.